Hello friends, let us build and simulate a stable multivibrator using the timer IC555. So from the component blocks, select a component. First of all, to find the IC, I will go to the mixed groups. In the mixed group, mixed virtual, I have the 555 virtual timer IC. We'll say OK. So this IC is required for designing of the circuit. Main role is played by IC555. Now along with these basic components as a resistor. So total 3 resistors are required with 1 capacitor. Let us choose 1 capacitor as well. Then we'll go to the sources family to choose the required VDD supply. You can give any label as well as the ground connections. So these are the components that are required for the building of the circuit. So the names of the terminals are given: VCC terminal, pin number 8, pin number out, pin number 3, ground is pin number 1, control voltage is pin number 5, trigger is pin number 2, threshold voltage pin number 6, discharge pin 7, reset pin 4. Now for the interconnection of all these components, okay, one more thing, that is a LED is also required as a part of the from the diode family. From the groups of diodes, I will choose one LED, LED with emitting light, red color. So I require one more LED to indicate the on and off of the LED. So this LED I will connect it in the output part. So as a limiting resistor, I will use one resistor of 1K value. Even the smaller value resistor will also work. Then along with that, 2 resistors are required here that decides the charging and discharging time period. So I will keep this of 470 kilo ohms. This is 1K and 1 capacitor in series with the resistor for the connection, and this is the ground connection. Required power supply, I will choose a power supply of 9 volt, that is sufficient to make the circuit work. Do the connections VCC over here. Then this is to be connected with pin number 4, which is a reset pin. We will connect it here. Then resistor to be connected to VCC. Join these 2 resistors with sufficient distance so that other connections, if it is there, that has to be done. Then this is a ground connection. So we can stretch down, and this is wire. From this I will connect it to the ground connection. Make sure that directly no 2 components are connected, otherwise connection would not be held. It seems as if it is connected, but it would not be connected at the back end. Okay, now what about the rest connections? So pin number 2 is to be connected to pin number 6, trigger and threshold. So trigger and threshold. So these 2 are to be connected with each other, and that common terminal goes to the threshold and trigger. Capacitor. So from the capacitor, so we will not be able to do this connection directly. So from this, do connect here, and now we can do the connection over here. Fine. 2 and 6 connected together, and pin number discharge pin goes here. Discharging path is through the R2 and C1. What else? So the output pin number is to be connected to resistor R3, which is to be connected to LED for limiting the current. Then do the connections, complete the connections with the ground. This is not connected right now in this application. So this is what the circuit is completed. Okay. Now if I run the circuit, yes, its LED is blinking. Okay, one thing is left. We should change its value. In earlier design, I have chosen it of 1 microfarad, but 1 microfarad using that charging and discharging is not discriminated by our eye. So I will make its value 1 nanofarad. The switching period will be reduced. Switching frequency, I mean time period will be increased. Yes, so this is frequency has been changed accordingly, so we can observe. So this is what the LED is blinking. Now same thing we can observe. I will stop the simulation and do the connections of CRO oscilloscope. So if I connect here the oscilloscope to observe the waveforms, so one terminal is connected to the output and negative is grounded. If I simulate the circuit, what I should get? I should get a square waveform at the output. So the square waveform indicates on and off of the LED. So to observe the details properly, I will still change the time scale. I will reverse the background. If I pause the simulation, so this is the waveform. I can go with changing the axis. See, so for this period it is on, for this period it is off. So this period can be changed by changing the values of R and C components, charging and discharging time period. So this is what. Now if we again simulate the circuit, exactly we may not be able to synchronize, but now it's in on state, so this is in the on state. See, now it is off. Recent cycle, it indicates it is in the off state, so LED is also off. So just we can compare this to map the waveforms and what LED indicates. So this is what the simulation of the Astable multivibrator is using the IC 555. Now we have built and simulated the circuit as a reference to the. So in the next videos we have shown the how to draw the schematic using the deep trace software and how to then go for the PCB designing of this particular circuit. As an example, I have chosen this circuit. Now how to go for that? Now in the same video I will show you how to install and from where to get the deep trace software. So if you just type the deep trace in the Google, you will be moved to the deeptrace.com site. So this is the page. From this, if you go to the download tabs, download deep trace into that option. Now here if you click here the deep trace 4.0 freeware, based upon your system, either it is a 32-bit or 64-bit, you can download the file. The file will be downloaded and its exe file will be downloaded. Just install it normally. Once you install it, there is no any specific key or the procedure to install or run the setup. It is very easy. You can do that normally the way we use the softwares. Now only thing is, once it is installed, if you go to the wherever the location it is in the C drive, suppose in my case program files, so this is the folder of deep trace. So in the deep trace it gives us with the different 4 functions that we can do. So here we can complete with the schematic diagram completion, and then here we can go for the PCB layout. And here the very well in the PDF form the tutorial is also available. Step by step all the things are explained nicely. So now if I open this schematic under the deep trace, we will be getting one window where schematic designing is very much similar to the multisim software. Once the schematic is over, then we can move to the PCB designing. So it asks us to, here the videos are also available. Deep trace forum, deep trace tutorial, guided tour video. Here the video is also provided which explains very nicely for the beginners. So from this we can start designing the schematic. From the components, choose the specific component from the list. This is about the schematic. Similarly, if you go to the PCB icon, it will open the screen with multiple icons, feature, files, options for designing of the PCB, where the PCB can be designed by importing the particular schematic. So automatically it will import your schematic from the schematic option, and once it is brought, then routing is optional. So run auto router, or it can be done manually. Manual routing also can be done for the, if it's a 2-layer PCB, then top and onto the base side, top and bottom. On both the layers we can manually route the tracks, or it can be done automatically.